Find the intervals on which the function is concave up or concave down. The function is g of x equals 2x squared all over the quantity x squared minus 4. In order to find where the intervals of concavity are, we need to go through and find the second derivative of this function. In order to find the second derivative, we need to find the first derivative. The first derivative using the quotient rule is the denominator times the derivative of the numerator, which is just 4x, minus the numerator, which is 2x squared, times the derivative of the denominator, which is 2x. All of that will be divided by the denominator squared. So x squared minus 4, the quantity squared. Before trying to compute the second derivative, the first derivative should be simplified. It can be simplified by distributing the 4x to each term in the binomial and multiplying the last two expressions together. So g prime of x will equal 4x cubed minus 16x squared, or just 16x, minus 4x cubed, all over x squared minus 4, the quantity squared. And with this simplification, you can see that the 4x cubed and the negative 4x cubed will cancel, leaving the derivative as negative 16x all over x squared minus 4, the quantity squared. In order to find the second derivative, the quotient rule would need to be applied again. This is the first derivative copied over from the first page. The second derivative will be the denominator, which is x squared minus 4, the quantity squared, times the derivative of the numerator, which is negative 16, minus the numerator, 16x, times the derivative of the denominator. You will need to use the chain rule to find the derivative of the denominator. When you use the chain rule, the derivative of the denominator is 2 times x squared minus 4 times the derivative of the inside, which is 2x. All of that will be over the denominator squared, which ends up being x to the fourth, x squared minus 4 to the fourth power. Now to simplify this numerator, it looks like in the first term and the second term, a common factor of negative 16 can be factored out, as well as 1 x squared minus 4. So in the simplification of the second derivative, I will have negative 16 times x squared minus 4, just to the first power. And that will leave us with an x squared minus 4 minus x times 2 times 2x to follow. And all of this is still over x squared minus 4 to the fourth power. And now that we have this simplified with the common factor, 1 x squared minus 4 can be canceled in the numerator and denominator, leaving us with a power of 3. And over here inside the blue brackets, this expression can be further simplified. So the second derivative is negative 16 times negative 3x squared minus 4 when the blue brackets are simplified. And that is still all over x squared minus 4 to the third power. The second derivative is copied over from the previous page. What we need to do now is find the possible points of inflection by setting the numerator equal to 0, and any vertical asymptotes by setting the denominator equal to 0. When the numerator is set to 0, we can solve for x by setting each expression with an x equal to 0. So clearly negative 16 will never equal 0, so we can just solve this equation right here, negative 3x squared minus 4 equals 0. And when you do that, you can add 4 to both sides to see that negative 3x squared equals positive 4. And then you can divide by negative 3 to see that x squared equals negative 4 over 3. And when you try to take the square root of this number, negative 4 over 3, this gives imaginary values. And we cannot have imaginary values because we're trying to put these numbers on a number line to find the intervals of concavity. The other thing we have to do here is set the denominator equal to 0, x squared minus 4, the quantity cubed, equals 0, which is the same thing as writing, if you take the cube root of both sides, x squared minus 4 equals 0. And when you add 4 to both sides and take the square root, you get x equals plus or minus 2. So these are vertical asymptotes for the second derivative, and these are the only values we can take to the sign chart. So on this page, the values that we found from the last page are listed here on the number line. And these divide the number line into 3 different intervals. And in each interval, a test value needs to be picked. And then the second derivative needs to be evaluated at each test value. So when you go back and look at the second derivative, which is here, and evaluate the second derivative at each test value, f double prime of negative 3, f double prime of 0, and f double prime of positive 3, the only thing that needs to be checked is that whether or not these values are bigger than 0, or if they are less than 0, and that will tell us whether or not a value is concave up, or an interval is concave up or concave down. And as it turns out, when you have these 3 values evaluated in the second derivative, you'll get that f double prime of negative 3 is bigger than 0, f double prime of 0 is less than 0, and f double prime of 3 is bigger than 0. What that means is that the interval to the left of negative 2 is concave up. And that's because when you evaluate the second derivative at negative 3, you have a positive value. This also means that the interval containing 0 between negative 2 and 2 is concave down, because that value was less than 0. And the last interval containing the test value 3 is concave up because the test value gave a second derivative value that was bigger than 0. So what you might think, by definition of the point of inflection, is that there is a point of inflection at negative 2 and when x equals positive 2. But in this case, that is not what happens. Since the x values negative 2 and positive 2 represent vertical asymptotes, it is impossible to give an exact x and y coordinate where the concavity changes. So we have intervals of concavity. Being concave up happens from negative infinity to negative 2, and again from 2 to infinity. And being concave down happens between negative 2 and 2. But there are no points of inflection because of the vertical asymptotes where the concavity changes.